The ACM-3000 is designed to determine short-term and long-term fracture conductivities of unpropped and propped acid fractures under downhole conditions of stress and temperature. Effects of the acid rock contact time, acid type, proppant embedment, proppant size, and concentration under high closure stress can be evaluated. The system encompasses an acid injection pump, a brine injection pump, 2 brine accumulators, a nitrogen gas flow controller, an inline heater, a 6-inch high-heated fracture conductivity cell, a hydraulic press, a number of pressure and differential pressure transducers, 2 back pressure regulators, 2 electronic balances, and data acquisition computer station. The cell mainly comprises a cell body, an upper and lower piston, and a set of right and left flow inserts. 3 pressure tubs and 3 leak-off ports on the upper and lower cell pistons are also provided. A lifting device eases loading and unloading operations of the cell. Unique removable end inserts enable a combination of acid etching, conductivity testing, and flowback testing to be performed in the same cell. Electrical cartridges are utilized to heat and maintain a homogeneous isothermal temperature profile in the conductivity cell. An insulation jacket covers the cell to prevent burns. Prior to each experiment, a fracture must be prepared. To do so, 2 slices of carbonate sandwiched by 2 slices of sandstone are stacked together to compose the sample. The junction between the 2 carbonate slices mimics the fracture. For fractures tests, a precise quantity of proppant is poured between the 2 carbonate slices. The stack is then coated with a thin layer of silicone rubber using a dedicated mold. Holes in the silicone sleeve are then made to connect the flow inserts and pressure tub ports. The coated sample is then introduced into the cell that has been previously greased. The acid etching experiment consists of injecting hot acid through the 2 coated carbonate slices spaced by a 3 mm gap into the conductivity cell using a membrane pump and a heating line. The acid is then cooled down before exiting the back pressure regulator. The 2 edged slices are then used with or without proppant for the next fracture conductivity test. The latter consists of displacing brine fluid through the sample while measuring the differential pressure and fluid flow rate across the fracture. Using the Darcy's law, fracture conductivity can be deduced. An alternative way of measuring fracture conductivity is to flow nitrogen gas instead of brine and use Darcy's law for compressible fluids. A nitrogen mass flow meter and a dedicated outlet metering valve allow nitrogen gas to flow through the fracture at different pressure points to determine fracture conductivity. 2 electronic balances measure the weights of the fluids produced during the leak-off and fracture conductivity measurement stages. The computer control station guides the user through a series of predetermined steps to conduct the test. It also provides predefined templates for fast and accurate test execution. It calculates and graphically displays test results and produces a complete professional test report. Thank you for watching our video, and we look forward to seeing you soon.